Continue, guys. Okay, I'm going to stop this dumping here, what I'm doing. So before we move forward, anything else like you could clarify about, because now what we are going to do is actually start playing with the data, like shaping the data to come up with something more useful than this, because this is raw data, right? This is basically the streams that are coming out of your phones. Okay? So, where are these lights? Here you go. Remember I told you that we would have this engine over here that basically is going to process the data. We call engine for now, just for the sake of making sure we abstract the concept first. But let's drill down a little bit about the implementation details. So every time that you are working with Kafka and you want to start actually processing the data, because now we are just storing, right? This is a topic, right? And what I did to show you the events, I dumped the topic. We call this dumping, just like you would dump a table into a file, for example, right? In a Kafka world, we have basically two ways of processing data, right? The first one is by using a technology that we call Kafka Streams. All right? Have you heard about Kafka Streams before? Okay, a few of you have heard about it. Kafka Streams is essentially a Java library as well as a Scala library, where obviously you can write programs in Java and Scala with it, and then you can express your event stream processing using these APIs. Right? It has a very rich set of APIs where you can basically create Java classes that implement interfaces, and the implementation of the interfaces you're going to express whatever you want to do with the processing, like aggregations, joins, or enrichment, and whatever you want to do. All right? This is one way to do it. And then we also have this persona here that we call KSQL, right? So what is KSQL? KSQL is basically a DSL on top of Kafka Streams. Ultimately, KSQL is nothing more than an abstraction for Kafka Streams, right? Why? For two reasons. The first one, believe it or not, there's a bunch of other people that doesn't program in Java, right? That doesn't have the privilege of write code in Java, right? And believe it or not, they don't want to do it. They don't want to become a Java developers. No, just kidding. You know this more than me, right? So there's a lot of people that would like to start playing with event streaming application, but they lack the skills of knowing how to program in Java, right? So that's why they can use KSQL, which is essentially a language, right? In the end of the day, but it looks like more SQL than actually Java. So it's simpler to write, all right? We tend to joke that internally at Confluent that it doesn't necessarily is for end users, because not all end users actually know SQL, right? It is a programming in the end of the day, right? It's not a little simpler than Java, but it still is programming, right? Personally, right, the actual difference between what you can accomplish with KSQL and what you can accomplish with Kafka Streams is essentially performance, right? In terms of, is there one thing that you can do only with Kafka Streams and you cannot do with KSQL, or vice versa? No. Everything you can do with Kafka Streams, you can do with KSQL, and vice versa. From that point of view, you're good with both of them, all right? However, KSQL has an advantage in terms of performance because it is a dedicated JVM for doing stream processing, right? So let me put it this way. Imagine that you have like a Spring Boot application, right? Your program is a microservices that you wrote that is going to do something, right? Whatever that something is, right? Using Kafka Streams, you can embed stream processing into your Spring Boot application or microservice to do whatever the microservice does, as well as stream processing, right? So far so good? We're on the same page? But because the Kafka stream processing is going to run within the JVM of your Spring Boot, guess what? What can happen eventually with your JVM? What? Garbage collection. Because now your microservices is using the JVM heap to accumulate, just look at this, a bunch of streams of events coming in infinitely into your JVM and keep coming and keep coming. What's going to happen with your JVM heap? It's going to increase a lot, right? There's no magic. Somewhere it needs to be stored. So if you use Kafka Streams, it works, but keep in mind that you have to do a very hellable sizing exercise for your JVM, because you have to accommodate not only your microservices data, but the stream processing data, right? And on heap. So that's a performance problem you might have. You might. I'm not saying that you are going to. You might. KSQL is a dedicated JVM where basically KSQL pulls data from one Kafka topic, do what it needs to do, and flushes the data into another Kafka topic, right? So your microservice over here can simply read the data. So it's not storing the data on heap. It's basically consuming, right? So it's simpler to use the memory. You want to make a question?
The KSQL is not, it's not inside the JVM. It's out. It's not inside the JVM. It's not about being inside it or outside. It's about being a dedicated JVM only for string processing. So you would have your JVMs for your microservices or Java applications, whatever they do, right? And you would have a cluster of dedicated JVMs that only does one thing, which is string processing, you know? And Kafka would allow the communication between your microservice and this JVMs, which is KSQL. Not sure if it clarifies what you asked. So KSQL is somewhat like a middle layer?
Middle. It's more like middle layer, I would say so. Yeah, if we remember the three-tier architecture from the 90s, yeah, I would say that data will come in from the front end, KSQL is going to process like your application server, and then it's going to provide data for your back end. So, yeah.
But in terms of memory efficiency, the KSQL is way more efficient than
Yes, definitely, yeah.
JVM, because it's not utilizing a certain section of JVM.
No, it's more because you are now separating the workloads, right? Your application is going to do only what your application does, and KSQL is going to do uniquely string processing. So two different JVMs, two different workloads, you know. It's more, instead of putting this workload inside your JVM, you are offloading it. That's more like a separation of concerns.
What kind of processing KSQL does actually? I assume some sort of transformation, maybe some mapping.
That's a very good question. Not in terms of, because I don't know the answer. You know, when people say, no, that's a very good answer, you don't know the answer. Because that's what I'm going to show you right now. But since you brought it up, yes, you can basically do transformations, aggregations, countings, joins. I'm going to do all of this right now for processing. The objective, remember, is to come up with something like this, a table, right? So we're going to come up with this right now. Yeah, go ahead.
So can you remove KSQL with this implementation here?
I
Will you
could.
still be able to do what you want to do, but only the performance can be?
I would have to use Kafka Streams, but yes,
So
I could.
both sides, yeah.
Yes.
So, but you can remove this from this implementation. But
Yes.
you expect that maybe issue with the performance.
It's more like because in this architecture over here,
Yes.
this layer does one thing only, which is string processing.
Yeah.
So for this architecture, it wouldn't matter if I'm going to use KSQL or Kafka Streams, because in the end of the day, they would do only one thing, which is string processing. However, there are some use cases, lots of them actually, where developers are using their existing applications that do something already, right? And they're bringing string processing into it. That's where they might have some performance problems, because now the JVM is doing not only one thing, but two things, you know? And string processing allocates lots of data, lots. Like the footprint of the JVM can be increasingly incredibly large. You know? But yeah, in this case, I could have used it, either one of them, but it wouldn't matter for the performance standpoint. So let's see how this works. And then let's play a little bit with data. I'm going to ask you to actually play a little later on so we can actually keep generating data. But for now, let me just, as it's here so we can see from the beginning. Okay. So here in the project, let me close this. AWS, Terraform. Here in the project, you're going to see this folder called Pipeline. Okay? If you expand this pipeline, you're going to see this queries.sql file. So I could run this file at once using it as a script, but I am going to purposely execute line by line so I can explain and you can understand what each line does. All right? So before that, I need to establish a session with KSQL. So KSQL is a JVM, right? It's a JVM that is running somewhere. In this case, specifically, it's running on AWS, right? Behind a load balancer. But it could be running anywhere you want. As I told you, it's a JVM, all right? Java minus jar, and then spin up a new JVM, right? Whatever the JVM is running, you should connect with this JVM to start publishing your stream processing semantics or strategies or topologies or logic, whatever you want to call it, right? So that's what I'm going to do right now. So I'm going to use the CLI called KSQL. You have to have installed locally in your machine, and you just specify the endpoint where your JVM is, right? In this case, as I told you, it's running on AWS behind a load balancer. So that's what I'm going to do. So this is what we call a client session with KSQL, okay? In this CLI, you can do things like show me the topics that I have it. I would have 2 topics, all right? The first topic, you see the streams that were coming out of your game? All of them are going to be stored in this user game topic, right? Every time you game over on Pac-Man, which means when you lose your 3, I think it's 3 lives, right? You have on Pac-Man. When you game over, it's going to emit another event that's going to this user losses. So it's 2 events, 2 types of events being emitted in different situations and different times, all right? Besides topics, which is the raw material of Kafka, you can also have streams, which I have none so far, and you can have tables. And tables are basically what the name implies, are tables, right? Just like a database, okay? So as you can see, I don't have streams and I don't have tables. The only thing I have is raw data and topics, okay? And as you know, events are coming into the topics, all right? So let's start playing with this data. The first thing I'm going to do, Kafka is a log, right? I was chatting with you before, right? But let me share with everybody what we were chatting before. So Kafka is a log, right? What that means is that it organized the data in the disk one after the other. It's a log. Just remember the logs for the stack traces of your Java programs. All line one after the other is how Kafka structures the data into disks, right? So what I just did is saying, I want you to move the pointer that usually is on the tail of the log, which is usually reading from the very last record. I want to move from the beginning of the log. That's what I did. Why? Because I want all the processing that I'm going to do that considers all the data reading thus far and all the data that is still eventually coming in, right? So I don't miss any data, okay? That's what I did. I moved the offsets, that's how we call it. And then we are going to create our first stream. It's blinking the screen for some reason. I'm going to create my first stream that I'm going to call user game as the name of the topic that I created. And basically the syntax is create stream, you give a name, And you see between parentheses, I am actually determining the layout of that stream. Look at this. I have a field called user, which is varchar. I'm basically modeling, let me just print user game from beginning so you can understand what I'm talking about. So this is the user field, varchar. Okay? Describe, extended, user game. And then I have this other field called game, right? That I've modeled as if it were a complex type. Complex types in KSQL and Kafka Streams, we use this keyword called structs. It's as if you were modeling like a Java class, right? That has properties and fields and all of this. So a game is a struct that has a score, lives, and level, right? So with this, you can start doing this. Instead of dumping, you can actually select streams. When you select streams, you are now actually fetching data as if they were something structured. Now you can start seeing like fields, user, and the field game, right? And because the field game is a structured field, you actually can, if I want to access this field over here, I could have written select user, game, but the field score from user game. Now it should show Chris B and the other user, and only the score field. You see? So you can reference, and this can be cascaded as well. You can have a field whose value is a struct that has a field whose value is a struct. So you're not limited to model as a flat table anymore. You can have complex nested structures in this, which is good if you are coming from the object-oriented world like Java. You can model objects more easily, thinking like this, right? And we're going to do the same thing with the user losses. So user losses is a little simpler because it only has the field user, and basically I count the number of times that this. Let me see actually how many of you actually have game over. Probably everybody, because you stop playing, right? And then Pac-Man is going to be dead, probably. Yeah, everybody die at least once, or twice, or 3 times, right? Which is okay. That's normal.
Question.
Sure.
So when you create the
Stream.
you pass the structure of the topic.
Yeah.
Since you know it, but the real world streams are complicated and sometimes you can make all kinds of mistakes. Is there a way to map, to read the structure of the topic?
Yes, that's where Alvaro come into play.
Okay.
You would have to use Alvaro. So Alvaro is able to actually read
Yeah.
the layout.
Because the structure is already there.
Exactly. But it's already there because when you serialize the records using Alvaro, you provided the
So
structure.
you register your schema and then
Exactly.
read it from the schema.
You got it. Yeah. Because otherwise, there would be no way to figure out the record, the layout. You got it right. Okay, so I created a string for user game, for user losses. Now, let's start playing with the data a little bit. The first step when you create event streaming applications is essentially do what I did here, which is bringing the representation of your raw topics as raw streams. Basically, these guys over here, we refer to them as raw streams. They are as dumb as the raw data. The only thing we did different here is that we specify a layout. It's not something useful yet. Now we are playing with the data. So look what I'm going to do right now. I'm going to create a new stream that I've called it user game rekeyed, right? Right here. And this user game rekeyed is basically selecting from the previous stream called user game, right? But I'm partitioned by user. So back to the question that I forgot who asked it before. I think it was you. about why you're not producing any key for the records, and I told you no, I intentionally am not using any key because now I'm specifying the key. Now I am picking one of the fields that you have in your previous stream, which is in this case is the field user, and I'm using as the key. So in your event streaming application, even though the record has no key, you can reinforce the key, the key field, using the partition by clause, right? Again, if you are doing this with Kafka Streams, the APIs allows you to do the same thing. There is a partition by method in the API that you could use, right? This is basically a DSL on top of Kafka Streams.
Can you ever combine key?
Yes, complex keys, exactly. It will be like you would have, for KSQL and Kafka Streams, you would have to come up with a Java class that represents your complex key, right? Package it in a jar file, put it in the class path, and then yes, you can start using here. Yeah, you can. And I'm going to, so if I select now, remember when I selected user game? Oops, from, right. This is the raw stream, right? If I select this, you see this column over here that has null? That's the key. That's the place where the key should appear if we had a key, right? But remember, I just selected the raw stream. Now if I select the rekeyed version of it,
Based on your exception, you're using Antler as your parser generator.
yes, yes, the implementation. Look how what the key is now. Yeah, whatever is the value of the user field is now being used as the key. And this is a timestamp. Basically, it's a timestamp that you can use for doing some time analysis of your streams. So now that we have the user game rekeyed, we can create a table for the user. So let me execute, and then I can explain. A table, what is the biggest difference from a table and a stream? A table is static, just like a database, static data. It doesn't change unless you actually load more data into that table, which eventually continues to be static. Streams never stops. Stream keeps coming in all the time, so you can recompute all the time if you want it. A table is a point in time version of a stream. Not sure if that overcomplicated things or if it explains what I'm trying to do. A point in time version of a stream is like, I want to grab a snapshot of that stream specifically on the last hour. That slice of the stream is going to come up with a table, all right? That's a point in time. Go ahead.
When you script select off from your stream,
Yeah.
so where is the cutoff for that stream?
It doesn't have a explicitly cut off, right? But physically, that table will always have a point in time. So imagine that you have a stream that nobody's playing Pac-Man anymore,
Yeah.
right? So the table will have only whatever has been played thus far.
Yeah, but the stream, what before the stream one, the one
Yeah, no,
you are select-
and the table, because the table, look, the table is basically based off on whatever is in the user game rekeyed,
Yeah.
right? So let's say that 1 minute later someone starts playing Pac-Man again, and then the stream is going to produce new records like inserts into the table, you know. So there will be new records into the table right now. So in other words, it's like a pipeline. It's like you would do in an ETL, for example.
Yeah.
If new records arrive, it's going to populate new data into the resulting table.
What's sequencing though? Like, is there like a timestamp or something you can get for this, or
For the table?
like you said, point in time, right?
Yeah.
Where is that time?
Yeah.
Is there a timestamp? Is there a
Uh,
sequencing number or something like that?
In this particular case, I didn't use a window clause.
Okay, so
That would delimit it like for the last hour, you know. So in this case specifically, whatever comes in the original stream is going to actually update the table. So that's what makes the table live. It's not static, you know. But it still is a point in time because it always flushes the data into the table.
What's that first number? Is that a
First number?
epoch, like that 157422?
Oh, that's a timestamp.
Okay, that's what
That's the timestamp when the record was stored in the topic.
Got it.
So we stamp with a timestamp.
Okay. Yeah, that's what I was asking.
Yeah. So when you use the window clause, it's based off on this
Got it.
timestamp. Yeah.
So that here, right, that the stream is constantly updating the
The
table.
table. Exactly.
I mean, what, is there an interval or is it just,
Technically speaking, is the interval I think is every 5 seconds for the table, and that's basically the main difference from a stream and a table, because a table needs periodically flush to update the results. A stream is alive; it's continuously updated, so there's no 5 seconds.
In what
Right.
kind of
You know?
point will be different between the table and the stream, right?
Definitely, exactly. There will
You
be
flush all the data from the stream.
the table conceptually will always be outdated when compared to the stream. For 5 seconds of point of view, like 1 second, it will always be behind of what streams is. If you want to know the source of the truth, you have to query the stream, not the table, right? Just like databases, if you think about it. Databases, not sure if how many of you know this, databases uses also logs
Yep.
underneath, right? So a table is basically a slice of that log. So here's the same concept, right? So here, look that we are now using constructions like aggregations. I think you asked it before, like what type of thing we can do. So here, we're using some aggregation and we are grouping by user, right? So that's the type of thing you can do with stream processing, one of them. And so we did this for user and we call stats per user. Now let's do the same thing with the user losses. So I'm going to create another stream called user losses rekeyed. Same problem because the original stream has no key and I'm using the user field as the key now. I'm partitioning by the key, right? As well as I'm going to create a table. Oops. I'm going to create a table that necessarily is going to do a summarization, just like I did with the other one, but is going to do a counting per user. Because user losses, per user, I would like to count how many times you lost on Pac-Man game. That's why I'm using the clause counting, right? For the user game that has your scores, that's different because I don't want to count. I want to sum your score, right? That's a different approach. So now, if we count the number of tables, we should have 2 tables now, right? Stats per user and losses per losses, right? Let's select stats per user for the sake of from
Select from.
and the star, right? All right, so let's see the layout of stats per user so you can have an idea about what we are building here. So now we have the first field is always the key, right? So now we have users, and then we have the column, the highest score per user. So for example, Ishmar, his or her highest score was 1,260, and the number of levels that he or she ended up with was 1. This is level 2. So basically, who here is in a better position than Pac-Man? I would say that's Cam.
Cam crushed it.
Yeah, because its highest score was 2,000, and he went through the 3rd level of Pac-Man. Right, so it's good. It's you?
I only played one.
All right. So we have 2 tables, right? Now let's create the final table, which is the scoreboard. So the scoreboard, look what we are going to do. We're going to basically unite all the fields from stats per user, all the fields for losses per user, and we're going to join them and using the user as primary key, and foreign key. So the 2 tables we have, we're going to consolidate into one. All right? That's what we're going to do. So let's create this table. Now we should have 3 tables. And if we select Scoreboard, we should have something similar to what we have here, but with one more field, which is the number of losses. You see? Score, level, and the last field is the number of losses. So we actually have a consolidated view of the scoreboard. But this is static. That's the main point of table. This is static data, right? So apparently nobody is playing right now. Could any one of you start playing again? Because this has to move. The select needs to be live. It never ends. By the time you start playing, these need to come up with new results.
While we're waiting for that, can I ask you a question?
Of course.
Do you have different language bindings for this KSQL so that you could, for instance, write something that looked more like Python or more like Java
No,
rather than KSQL? This
not
SQL?
yet. Not yet. But we have an internal project of it where we're going to bring more programming languages to express what you can express today as in Java and SQL. Yes, Python is definitely one of them. Node.js, Kotlin, Go. We are basically coming up with this implementation for this.
For the KSQL?
For
for
string
everything.
processing. For string processing. So
Okay.
as a developer, as a Python developer, as a Kotlin developer, you would like to express event string processing semantics with your favorite programming language. You know,
Okay.
that's, yeah. But it's not there yet, unfortunately. It's going to take some time. So let me show you this in a different way, right? Because this is the result of a select, right? So as you can see, some of the records keep repeating, right? Because why it repeating? Because it's repeating, showing the new status of that record. That's why it's repeating. Let me show you a different view that's more likely a table.
So could you do a sort by as well?
Like a order by?
Yeah, order by.
We not at this version. That's a good question. So order by clause is being introduced right now. We have a preview on KSQL 5.4. This is version 5.3.1, which is the GA version of KSQL. We're introducing order by, but only for tables, which makes sense, you know, because it's static, right? Yeah. Probably it's coming out in December. It's going to be GA. Let me grab what current directory I have here. PWD. Yeah. Let me grab this. Let me CD there. Let me go back to folders. Oh, CD. I have this folder called Scoreboard. Now, that's the part where I'm going to ask you sorry in advance for this. Why? Because this scoreboard that I have here, I have written in Go. I'm sorry, right? Time out. But there's a reason for this, because as a developer advocate, I have to engage with different type of communities. So I took the decision of write the Lambda function in Java and the scoreboard in Go, so I can
The next vote.
yeah. So
you always have to apologize.
always, if I go with the Golang community, when I show the Lambda function, I'm sorry, but I'm not taking any sides. You see? Right, go ahead.
How can you do without abstract base class?
A what?
How can you do without an abstract base class?
Exactly, right? Now, there's a lot of things that Go cannot do very well, like we would do in Java.
That was a joke.
Yeah. No, I know, I got it. So what this program does, and I could easily have wrote in this code here in Java, is basically create a consumer, right? And this consumer is subscribing to this topic called Scoreboard, which is, oh, I forgot to mention this. That's important. Every stream and every table that you created, either in KSQL or Kafka Streams, ultimately is going to create a topic. In the end of the day, the unit of storage of your streams and tables are Kafka topics. All right, so let me put it this way. Let me connect to KSQL again. If we show topics now, look at this. The unit of storage is always topics, right? So as a developer, you can do the same thing that you would do without knowing this whole Kafka Streams or KSQL part, which is subscribe to topics and start fetching the records as they arrive, right? So that's basically what I'm doing here in this code. I'm subscribing to the topic scoreboard and printing the results. So let me do what I was going to do. Clear, go, run, scoreboard, go. It should present a table with the output. Yay, here it is. But now, if you keep playing, it won't repeat the records. It will keep the same records and only update the values of it. Like a table. Like a table. Like a decent database table, right? So if you care to play right now, just to check this idea. Actually, there is one thing that I could use your help while you are here. Do any of you know any Java framework that I could use to print a table like this dynamically? Because the problem of doing this, I could do a Java code that does it, right? There will be some logic, like rearrange the characters by using some algorithm, right?
On your console.
A what?
It has to be on the console.
Yes. Yeah. I couldn't find, I didn't search very well, but I couldn't find any Java framework that would do this. And this is something that is kind of easy to do in Go. In Go, we have this constructs over here like this. You see, I can define this. It's going to have 16 characters of length, and no matter what string it comes in, it's going to fit in automatically. So that's something you could do. And I couldn't find a decent replacement in Java. I'm pretty sure there is. I only don't know what framework it is. So if you come up with something, send me an email with the...
Just one line.
Just writing it a method shouldn't be. Why would you create another framework?
It's more to make it pretty, like the table, you know, like columns and all of
I
this.
don't know. Rather than spending researching the framework, writing the method itself would be, I don't know.
Yeah. I probably am going to spend too much time rearranging the characters, so I wonder if there's a framework that would
You
allow
have
me
to be able to update the console and write about, like, a line that is already written has to be
Because
rewritten.
here's the thing.
That's
Imagine
Yeah,
Imagine that
that's repeating that.
imagine that your name
I think we're doing it.
imagine that your name is Arnold Schwarzenegger, for example. So your name is going to push all the columns forward, you know? That's the problem I'm trying to tackle.
Yeah,
with.
yeah,
That's the
Well, but that's, you just use string format from Java.
the
String format, and you can specify exactly the widths and everything.
Really? I've never done this. We
Yeah,
can't?
string, it's a string, it's part of string class.
Like a formatter of
Yeah,
string.
string.format, it's a method, and you can format whatever the string you want to
And you
do.
specify the length of each.
Exactly like you did with the percentage and everything.
Like you do in awk or Python
Yeah.
or something like that.
Okay.
Yeah.
Okay, I'm gonna try that.
But the problem I see is just having to rewrite on top of a line that has already been printed on the console. I don't know how to do that.
Ah, yeah. So yeah, I have to do some work around here in Go as well. So basically what I do, every time I print the statistics, the first thing I do is clear screen, see?
Yeah, that's.
So clear screen is essentially what I'm doing.
Redrawing it.
This is
Do we
the
have that
workaround, you
method in
see?
Java to
I'm
clear
running
screen?
clear command.
Yeah.
With Java would be runtime.getRuntime.execute
runtime.
clear.
Yeah, the problem here is we have a back-end engineer trying to do front-end work, that's the problem.
Exactly,
There
right?
should be just a web page, right?
Yeah.
A refresh.
Yes. Refresh.
I have a question.
Sure.
KSQL, does it provide a typical CRUD operation or just mostly for retrieving?
Good question. So essentially, we support inserts, obviously, because you're always appending records and events in the
Yes.
tail of the log. For tables specifically, we support inserts and updates, where the update, basically you are appending a new value on the tail of the log, and the primary key is pointing to this new value. That's the magic we do. We do not support deletes, right? And probably will never support, because the whole purpose of streams and logs is to be immutable records, right? Like that's the same concept for like Bitcoins. Not the concept behind Bitcoins is a ledger. Is a ledger, distributed ledger. So the records has to be immutable, and that's what makes the source of the truth what happened.
A blockchain.
Blockchain, for example. So if you have deletes, you can forge a truth. So in streams, you should not be able to do this.
So doesn't a problem with this space eventually arise if you just keep accumulating? I mean,
yeah, that would be a problem. But in Kafka specifically, every topic you can enable compaction. So what compaction does is, if you have a key in your record, in a per record basis, which we now have, right? So compaction enable, it will only save the last state of the key instead of the whole log. So in other words, if I Ctrl C over here, just to prove the point, it will only save this value of the record for Miriam. It won't have the historic of the streams. It will delete all the historic of the streams if you have compaction enabled. So you would do this for certain tables that you would have in your implementation. But for the ones that you need to have the historic, you have to disable the compaction. But you're right. I mean, you would end up with a storage problem. You have to size your Kafka cluster accordingly for making sure
your source stream is something that you typically wouldn't use compaction on. Is that correct?
Yes. I would say that the tables, all the use cases that were tables, you would have compaction.
Okay.
Because it's a point-in-time version of the truth. But your actual streams is your source of the truth.
Yeah.
Okay. Yep.
So question about the KSQL server or JVM.
JVM.
Real life scenario is adding more tables, topics and so on. How does it scale? Is there a performance issue?
Scalability-wise, KSQL or Kafka Streams are no different from typical Kafka consumers. And a matter of fact, Kafka Streams has been built on top of the Kafka Consumer API. So the same scalability techniques that you will use for a typical Kafka consumer, it applies for Kafka Streams, that in turn account for KSQL. So in other words, you would do partitioning of your consumers in order to achieve scalability and parallelism or concurrency. So that's how you do this. So yeah, basically just set the number of partitions and you're good to go. Your scalability limit would be the number of consumers that you can execute in your cluster. The KSQL server also has this concept of thread pool as well. So that's usually, it's like there's no black magic. The thread pool for each JVM for a KSQL server would map the number of virtual CPU cores that you will have in a machine, right? So if you have 16 cores, it's usually a good idea to put the thread pool up to 16. So that's your basically maximum level of concurrency that you would have on a per JVM basis. But that is not like a rule of thumb, because some people can execute more than one JVM in a node, right? So if that node has 4 cores, conceptually you would have a thread pool of 4. But if you run 2 JVMs with set thread pool of 4, you would end up with 8 threads, right? So you would have some context switching between your JVMs, which is not good. Yeah, it's basically the same practices that you would do in any application server that you would, like WebLogic, JBoss, or something like this.
I have a storage-related question, actually, follow-up on the Eric's. Is there any option for the Kafka, let's say, I have a sequence of events coming, but maybe I don't need the latest one, I mean the earliest one.
The previous one?
Is there any size limitation that I can specify? So
Oh,
all the
yes.
streams are filling up that space, but not going beyond that space?
Yes, definitely it is. Actually, this technique that I'm going to explain now has nothing to do with streams or KSQL. It's something that Kafka provides out of the box. Is the concept of retention period. So in a per topic basis, you can set the retention period of, it's by default is 1 week, right? So you can increase or decrease this, like for, yeah. And we are introducing, remember, I think you asked it for the order by clause before?
Actually, my friend.
Yes, he asked it. So in the same release that we are introducing the order by clause, we're also introducing another feature in Kafka, which is the concept of tiered storage, which has to do with something that he just asked it. So you can have retention period per topic, right? So today you can say, I want to store data for 1 year. You can do this if you want it. If you have storage for this, you can do it. And a lot of people likely do this for like keeping the storage or like a blockchain, as you mentioned before, like holding the source of records. But it all boils down to have storage, and storage has cost, right? So today, the primary unit of storage of Kafka is disk, right? So imagine that you were running this in the cloud, for example. You would have to pay for block storage, which costs money, right? So the tiered storage that we are introducing is going to allow you not only to store data permanently, but in different tiers of storage. So you can say, for example, I have a topic called transactions that I want to keep all the hot data for the last 3 months and disks. And everything beyond 3 months is going to overflow into an object storage, which is cheaper and has a better like a durability and replication across regions. So, and this is going to be automatically. Like, remember when we did this in the code, when we moved the offset to the beginning of the log for processing everything. If you do this in the tiered storage, it's going to retrieve from the object storage automatically and reload into the hot storage. So for the developer perspective, you simply say, read. I don't care about how the storage is going to be filled up or overflowed. So it's pretty cool. We're introducing right now.
So what is Fortnite doing right now with all of that tiered storage?
They actually using storage, block storage, and they're paying lots of money for this. And pretty much, customers like them is basically what stimulated us to create the tiered storage, because in the end of the day, like the typical Kafka infrastructure can become very expensive if you hold lots of data across time, you know. Because that's the beauty and the problem of Kafka clusters. Kafka is not a very expensive technology because it's not CPU bound. Kafka clusters are not CPU bound. Kafka Streams are, KSQL are CPU bound. But a typical Kafka broker is disk bound and network bound, so it's cheap. Like cheap considering that the most hardware expensive resources is CPU, right? So, but storage can also be really expensive these days. So that's why we are introducing this feature. Yeah. So yeah, Fortnite, Epic Games, they're spending lots of money with I think their cloud provider is GCP. That's what they use.
So what's the best practice? Normally, obviously, you're going to process your data in your transactional database, maybe, right? And also put Kafka Streams for further analysis or creating that type of...
Good question. What we encourage people to do is actually bring all the data to Kafka, because Kafka is going to be cheaper than a typical database deployment, if you think about it, right? And Kafka can deliver data for multiple destinations if you want it. However, the typical use case that we have seen in the field is that you already have some transactional database and you can apply CDC techniques. And there is some CDC connectors, like Debezium is an open source project from Red Hat that provides some CDC connectors. So we can keep pulling the records from the database, bring it to Kafka, and then we can do the processing there. But why? The key question is why you would do this? Because it's cheaper than doing the processing in the database. You can save lots of money with database licenses. We can save lots of money with database infrastructure and storage and all of this. So it's a nice deal. There's a bank in Canada called RBC. You can check online for their use case. It's public reference. They basically offload the entire DB2 database from the mainframe and put data into Kafka. So basically they save lots of money doing this. That's the beauty of Kafka. It's not only about scalability. It's about implementing database strategies in a much cheaper way. That's one of the most popular use cases for Kafka these days.
So if you're using Kafka and going to AWS, there's different solutions there.
Mm-hmm, mm-hmm.
Can you elaborate?
Like, for example, MSK? Kinesis is not Kafka. It's similar to Kafka because it's a pub-subscribe type of thing, but it's not Kafka at all. And I'm not very familiar with Kinesis, like I've never worked with. I've worked with MSK. I can talk about a little bit about how it works and if it's good or not. But Kinesis is basically, if you're looking for pub-subscribe, it's good. It's good. It will be a replacement for Kafka. But if you're interested specifically in pub-subscribe, you know, like remember the conversation we had before about messaging? What's messaging? Move data to point A to point B. We don't have to store, right? So yeah, Kinesis is good for this.
So basically, if you use Kafka as a database, what about maybe backing up the database? Or do you need to, because redundancies or different partitions? What's your take on that one?
So we provide strategies for like dumping all the content for Kafka topics to like tapes or other durability strategies that you would come up with. We have something called Confluent Replicator that could help you to replicate data from one data center to another and keep them in sync for DR purposes, for example. So pretty much all the techniques that you would apply for a typical database, you can do with Kafka as well. So like, which is basically flush into tape to recoverability purposes and replicate across regions for DR purposes. So that's, yeah, we can do it.
Question. So what's your opinion between Kafka Stream and Flink?
I don't have actually any because I've never worked with Flink. I've heard about it, like I know that's a string processing framework, but I've never worked with Flink before, so I don't have any. Have you worked with it? Like how it look like?
I haven't used it for production, but I can't
Okay.
play with it.
There is a guy in our team, he's part of the engineering team at Confluent that is a commuter for Apache Flink and Kafka Streams. I can ask him if you want it. If you want to send me an email, I can ask him about if you had any feedback about performance, because he commits code for both projects, Kafka Streams, and he's this guy over here. Like, if you want to grab his. That's another guy that I follow. Never mind. Matthias J. Sachs. He's a commuter for both, you see? Kafka Flink, Kafka Storm, and Kafka Streams. He commits a lot. And he's very good. I mean, I can ask him if you want it. He's an Apache commuter for the 3 projects, so he knows, he would know if there is any difference between Flink and Kafka Stream.
Okay, I'll do it.
Yeah, if you can send me an email, I can introduce you to him. I forgot to share this as my contacts here. So this is my email. If you want to send me any further questions about Kafka and other things, if you want to follow me on Twitter, GitHub, or LinkedIn, basically I've made it easier for remember, which is basically this. So,
Given the dependency to the storage, what's your take on running Kafka in a Docker container on Kubernetes where you don't have like the storage that is easily accessible?
Yeah, no, that's the service that we use it here, the Confluent Cloud stuff. We run Kafka on top of Kubernetes. But in order to do this, we have to solve the problem of how to manage stateful sets. So for this, we've created a Confluent operator, a Kubernetes operator that basically abstracts the persistency capabilities. And we have Helm chart, which is open source. So if you want to run Kafka on Kubernetes, we have Helm chart. On Docker, you would pretty much have to kind of figure out by yourself, like how to attach volumes to the containers, non-ephemeral volumes.
But it kind of,
Works fine. I mean,
performance goes down, right? I mean, you always.
Yeah. because you are basically virtualizing the storage, right? So there's a additional I/O round trip that you would have to do. So performance-wise, I would say that you would be better off with running on top of Kubernetes than actually running on Docker containers. Kubernetes is faster, believe it or not. Using the operator. Using the operator.
Questions?
So question, back to the original question, Amazon MSK.
MSK, yeah.
Yeah. So how would it compare to, deploying directly Kafka to AWS versus using MSK?
When you say Kafka directly is like having your own Kafka cluster?
Yeah.
There is no fundamental difference. Basically, what MSK provides you is a Kafka cluster, but managed by AWS, right?
Right, so you don't have to deal with management.
Exactly, yeah. There's one thing that I don't like about MSK, and it's basically how they designed their service. You know the concept of VPCs, right, in Amazon, in AWS, right? So a VPC is where you spun up all your compute and storage resources. So you have to provide your own VPC for spin up the Kafka cluster, which is okay this far. However, they have a limitation of all your producer and consumer applications has to be running within the same VPC to have network communication, or you can run in your own VPC, but you have to peer the VPCs. What's the problem with this? It kind of creates a lock-in with AWS, right? Because you have to run your applications in AWS in the end of the day. So it's different, for example, what we did here. I'm running my consumer and producers on my laptop, and I'm communicating with something that's being managed. It's running on AWS, but not necessarily is running within the same VPC, So that gives us more flexibility. So you might have situations where you want to run your producer and consumer applications on GCP, for example, but your clusters, it could be running on AWS. So it's more like a cloud lock-in flexibility. But for the cluster itself, it works fine. MSK is a Apache Kafka cluster, like the same one you would have in your data set. Yeah, works fine. Sorry, you were
I was just asking if Kafka is platform independent?
It's platform independent, not exactly, very good question.
Okay.
It is because it's written in Scala, in the end of the day it's a JVM, right? So conceptually you would be able to run this on every operating system that exists. But there is one thing that it doesn't allow you to run on Windows.
Okay.
You cannot run
So it runs on all flavors of Unix.
Unix-based
Or
system.
Linux.
Yeah. And actually, there's a good reason for this. Not sure if you... we have that?
We should be wrapping up pretty soon.
Okay. So I think that the reason why we don't support Windows very well is a good reason, in my point of view, but let me show you here. I've made this presentation in Brazil, in a Big Data Week, São Paulo, a couple weeks ago. Let me grab the URL, and I can reuse the slides from there. It will be in Brazilian Portuguese, but I will translate for you.
It's Kafka in Portuguese now.
Yeah. All right, let me go straight to the point that actually matters. Yeah, here we go. So, the reason why we don't support very well Windows is because, remember when I told you that all the records in Kafka goes to disk, and you can actually change that? It's persistent by nature. It goes to the hard disk, right? And all the copies of the file, the records, goes to the OS page cache, right? For two reasons. First, because it is a very good storage, because you don't necessarily have to store on heap, and you can have more density in terms of memory. However, when a consumer subscribes to a topic, it would be connected into a partition, right? and it would start fetching records from that partition, which is okay. So that partition is going to read all the records that are kept in memory, okay? Now let me make a parenthesis here, because this has to do with this API here called sendFile. Have you heard about sendFile before?
Yeah.
It's a Unix type of API that therefore is not existent in Windows platform business. What these APIs allow you to do is to bypass some layers of the network. You know the Ethernet layers have 7 layers of the network. The very up is the application layer, and the very bottom is your network card, right? So in a typical Ethernet architecture, every read and write you do across the network, you have to create buffers and copy the data between the layers, right? In this sendFile here, the application layer writes directly into the network card. So that's why Kafka is so high throughput, right? We bypass all the network layers, and that's why everything in Kafka is an array of bytes, right? It doesn't have a format. That's because the sendFile APIs doesn't support formats. Everything has to be an array of bytes, so we can actually write in the network card. So because of this API, which is good if you think about it, because that gives you the scalability and high throughput that Kafka provides to you, it's not available on Windows platforms.
So no TCP or IP protocol between the application and
Not the way other application would use. It is TCP IP at the end of the day, but it's not actually, the problem of TCP IP is the need for creating buffers between each layer, and more importantly, on every copy of the buffer, burning CPU cycles to making these copies, right? So by writing straight for the network card, we don't burn CPU cycles, and we saves lots of memory with these buffers, you know. So that's the beauty of the sendFile API.
I think this would be a good.
Yes, no, I'm done. I'm just answering questions.
All right. Very good. School night, so we want to
Yeah.
get this. So anyhow, thank you.
No, thank you.